Good morning, everyone. This is one more session with respect to Linux system programming. So, before starting with the today's session, if my voice is clear as well as able to see the screen properly, please type 1 in the chat box. If my voice is clear, able to see the screen properly, please type 1 in the chat box. Please type 1 in the chat box. If my voice is clear, able to see the screen properly, please type 1 in the chat box. Okay, thank you very much. If you're able to recollect, what is the discussion happened in the last session? In the last session, we started with file handling using the system calls. We started discussion with file handling using the system calls. Now, can you tell me, upon success, what is the open system call returns? What is the return type of open system call upon success? Can I say it is a file descriptor? What is a file descriptor? A small positive integer. File descriptor is nothing but one small positive integer which is used to do the file based operation. Now, upon failure, what is that open system call returns? Upon failure, what is the open system call returns? -1. What is the first argument of open system call? Path. Second argument is flags. Third argument is mode. The third argument we need to only use when we are using o_create flag. The third argument we need to use only when we are using o_create flag. Now, will you agree? Open system call is not basically creates the file until and unless you use o_create flag. Will you agree? Open system call basically will not create the file until and unless you use o_create flag. In a flags, will you agree there are two categories will be there? One is a mandatory flags and another one is a optional flags. There are three mandatory flags will be there. There are three mandatory flags will be there. One is o_rd only, o_wr only, o_rdwr. There are so many optional flags are there. o_create, o_truncate, o_append. These are macros. Now tell me, if you want to set multiple flags, what you need to do? Which operator you need to use? If you want to set multiple flags, which operator you need to use? Can I say bitwise OR operator? Okay. Now can you tell me, when your process is created, when your program is loaded into the RAM for execution, how many files are automatically opened? How many files are automatically opened? And what are the file descriptors? Numbers. Can I say there are three files are automatically opened? That is std in, std out, std error. Can I say file descriptor 0, file descriptor 1, file descriptor 2? So that is the reason in your program, if you open a new file, you are getting the file descriptor In your program, if you open a new file, you are getting the file descriptor 3. Lowest positive available number. How many files a process can open? You know that 1024 files. Yes, sir, there is a limit. Now observe this program. Now observe yesterday's last program. Yesterday's last program. Try to understand what happening here. So whenever a process is created, file descriptor 0 refers to in, file descriptor 1 refers to out, file descriptor 2 refers to error. Will you agree? Whenever your program is loaded into the RAM. Now observe, in this line number 4, we are closing the file descriptor 1. In line number 4, we are closing the file descriptor 1. Now can I say file descriptor 1 is not referring to any file? Can I say it is a free? File descriptor 3 also free. File descriptor 4, 5 up to 1024, those are free. Will you agree? Those are free. Now you tell me, after closing the one, we are opening a data file. After closing the one, we are opening the data file. Can you tell me what is the file descriptor number you will get in this FD? Can you tell me what is the file descriptor number you will get in that FD? Will you agree? You will get 1. Now can you tell me after line number 5, where that file descriptor 1 is referring? After line number 5, where the file descriptor 1 is referring to data file. After line number 5, file descriptor 1 is referring to a data file. Now you tell me this printf, where it will print the data? Can you tell me this printf, where it will print the data? It will not print std out now. It will print the data into a file called data file. So till now, in the C language, what we observed is printf means it will print the data on the monitor. Will you agree? Printf means it will print the data into the monitor. But what we can do, we can use the printf to print the data into the data file. We can use printf to print the data into the data file. So the conclusion is printf will print the data into the file whose file descriptor is 1. What to do? The conclusion is printf prints the data into the file whose file descriptor is 1. Again, the conclusion is printf will print the data into the file whose file descriptor is 1. Now, can you tell me whose file descriptor is 1 here? Can you tell me whose file descriptor is 1 here? Data. So that is the reason the printf hello world is printed. Printf hello world is printed into the data file. Let me compile the code. Let me show you the output. So observe data. Will you agree? Hello world is printed. Now observe, I'll modify this program. It is working like a fprintf. Yes. I'll modify this program. Observe, int a of 5 is equals to 10, 20, 30, 40, 50. Int a of 5 is equals to 10, 20, 30, 40, 50. Okay. Now you observe, I'll comment this. I'll use a for loop for I'll use a for loop for I is equals to 0, I is less than 5, I plus plus printf percentile d space a of I. Now this for loop, this printf, where it will print, this printf, where it will print into the file. This printf, where it will print into the file. Let's observe output here. I'll show you the data file. Will you agree? 10 space, 20 space, 30 space, 40 space, 50. Similarly, can I do the reverse program? Logically think. Can we do the reverse program where scanf should not scan the data from keyboard. It need to scan the data from the file. Scanf should not scan the data from keyboard. It need to scan the data from the file. Answer is yes. First you need to close 0 and then open a data file. So that in this data file 10, 20, 30, 40, 50 is there. So scanf will scan the data from there. So that the scanf will scan the data from there. I'll show you the reverse program. 2509 underscore 1 dot c. Hash include header dot h void main int a of 5. Can you tell me what is the storage type of a here? What is the storage type of a here? Can you say auto? Default garbage values inside it. Default garbage values inside it. Now open system call data file o underscore rd only. Now can you tell me what is this fd holds? What is this fd holds? 3 because I'm not closing it b9 p2. Try to observe it. 0 1 2 is already reserved, so it holds 3. But if I close 0, now you tell me what is the fd holds. If I close 0, now you tell me what is the fd holds. Now fd holds 0. Now for I is equals to 0, I is less than 5, I plus plus scanf percentile d ampersand of a of I. For I is equals to 0, I is less than 5, I plus plus printf percentile d space a of I. Now this scanf will scan from file descriptor 0. This scanf will scan from file descriptor 0. Now file descriptor 0 is referring to scanf will scan from file descriptor 0. File descriptor 0 is referring to can I say data file. Now let's see, this is called as input redirection. This is a input redirection. Previous one is output redirection. Now can you tell me what happens when you type ls command? Can you tell me what happens when you type ls command? Can I say it will display the list of files in the present working directory? When you type ls greater than, now observe what happens here. When you type ls, it will display the result of ls on the screen. Will you agree? It will display the result of ls on the screen. When you type ls greater than some file name, ls greater than some file name, so the output of ls will go to that particular file. The output of ls will go to that particular file. That is called output redirection. That is called output redirection. That is called output redirection. Is that is clear? Is that input redirection, output redirection? Is this concept is clear? So the example, same example, whatever I discussed, it is there. Array of 5 integers. Please respond it. Is it input redirection and output redirection? Is it clear? Next important discussion interview point of view. Next important discussion interview point of view, that is interprocess communication. One of the student is asking me to repeat here. Now observe. Normally scanf will scan the data from the keyboard. The student ID is B9S8. Normally the scanf will scan the data from keyboard, but here this scanf will not scan the data from the keyboard, it will scan the data from the data file. Why? Because file descriptor 0 is not referring to std in, file descriptor 0 is referring to data file. Why file descriptor 0 is referring to data file? Why? Because I closed 0 and I opened the data file. So what is the lowest positive available number here? What is the lowest positive freely available number? What is the lowest positive freely available number? 0. Now can I say, now file descriptor 0 is referring to data file? Will you agree? File descriptor 0 is referring to the data file. So now this scanf will scan the data from the data file. I hope you got now. Now this scanf will scan the data from the data file. Already in the data file 10, 20, 30, 40, 50 is there. So this concept is called as, this method is called as, this mechanism is called as redirection. So using the printf, we can print the data into the file. Using the printf, we can print the data into the file, and using the scanf, we can scan the data from the, using the scanf, we can scan the data from the file. So this overall discussion is called as redirection. I hope it is clear. So the next important discussion is interprocess communication, IPC mechanisms. In this IPC mechanisms, we are going to talk pipe, we are going to talk FIFO, we are going to talk message queue, we are going to talk shared memory, we are going to talk semaphores. Again, in this IPC mechanisms, we are going to talk in this chapter, in this discussion, we are going to talk about a pipe, FIFO. FIFO is also called as a named pipe, message queue, shared memory, and a semaphore. So before this, we need to discuss what is the requirement of this, what is the need of this. Now tell me, there are multiple works are there. Just a minute. Now tell me, there are multiple works are there, W1, W2, W3, W4. All these works done by one process, is the performance is good, or all these works are shared by multiple processes, or performance is good. Again, there are multiple tasks are there. Task 1, task 2, task 3, task 4. There are 4 tasks are there. All these tasks done by one person is good, performance is good. All these tasks done by different processes, different persons is good. Can I say work sharing is a good? Yes, sir. Work sharing is a good. So suppose this task, what it need to do, it depends upon this task output. Meaning is, will you agree, all these processes need to communicate between each other? All these processes need to communicate between each other. Hmm? Process means, can you recollect? Process means, can you recollect? Process means the program which is loaded into the RAM for execution. Process means the program which is loaded into the RAM for execution. Will you agree? So here, how many processes are there? Here, how many processes are there? Process means the program which is loaded into the RAM for execution. Here, how many processes are there? 4 processes. Those are independent processes or dependent processes? Those are independent or dependent? Answer is, those are dependent processes. This process is depends on this process is depend on this process, because all these are a part of one big work. The big work you divided into small works. So all these works are dependent. B9S8, getting the point? All these works are dependent, not independent processes. Dependent. If they are dependent, will you agree, they need to exchange the data? If they are dependent, they need to communicate with each other. They need to transfer the data. They need to receive the data. Then only the big task is done successfully. If they are unable to communicate between each other, the task is not going to be performed properly. So every process is having its own code section, data section, heap section, and stack section. Now my question is, can one process access the memory of another process? One process can access the memory of another process? Answer is no. Now can you tell me, when one process is accessing the memory of another process, then what happens? When one process is accessing the memory of another process, then what happens? Will you agree? Segmentation fault. When one process is trying to access the memory of another process, will you agree, you will get runtime error? So will you agree, operating system is designed in such a way that when one process cannot access other process memory, Operating system is designed in such a way that one process cannot access other programs' memory. Now observe this point here. Observe this point here. The processes are executing concurrently in the operating system, may be either independent processes or cooperative processes. Again, the processes executing concurrently in the operating system environment may be either independent processes, maybe either independent processes or cooperative processes. What is the meaning of independent process? Observe. A process is independent if it cannot affect or be affected by other processes executing in the system. Again, a process is independent if it cannot affect or it cannot be affected by other processes. Means this process is independent, it will not affect to any other process, other processes cannot affect the execution of this independent process. Any process that does not share data with any other processes is independent. Again, any process thus that does not share the data with any other processes, those are independent, those are treated as independent processes. All of you are getting the point. Till now, whatever the processes we created is cooperative processes or independent processes. Till now, whatever the processes we created, is it a cooperative processes or independent processes? Independent. One process is not sharing the data with another process. Independent. Now, observe what is the meaning of cooperative process. A process is a cooperating if it can affect or be affected by other processes executing in the system. Cooperative processes means a process that is a cooperative if it can affect or be affected. It can affect it be affected by other process. So what is the meaning is any process that shares the data with other processes is a cooperative process. What is the meaning is any process shares the data with another processes, then those are cooperative. Any process will share the data with another process is a cooperative. Is that clear? There are several reasons for providing an environment. There are several reasons for providing an environment that allows process cooperation. Information sharing. Since several users may be interested in the same piece of information, you must provide an environment to allow concurrent access of such information. Like if you take an example, you are accessing one website. So can I say, not only you, there are so many other processes in a world, they might have accessing the same website. Yes, sir. So then that is a independent process or cooperative, means they need to share the data. Now can you tell me, in your smartphone you will receive an SMS, will you agree? In your smartphone you will receive an SMS. So there are some applications which will read your SMS, OTP, whatever it is. Asal. So can I say that is a cooperative processes, information sharing is happening. SMS receiving is a separate process. Your app is reading that SMS is a separate process. Location sharing, will you agree? Location sharing, you'll give the permission to your app to access your location. Do you know there is a maps application will be there in your mobile smartphone, which will track, yes, GPS, which will track your location, and other applications in your mobile will access that location. Other applications in your mobile will access that location. Suppose in simplify say, in your mobile there is an application called maps. Will you agree? In your mobile there is an application called maps, Google Maps. So what it will do is it will keep on tracking your location, and it will put the GPS data, latitude, longitude, or whatever it is. It will put the data into one particular place. So whatever the apps you given the permission, can I say those acts, those applications, apps need to access your location. All of you are getting the point. All of you are getting the point. So can I say here these processes are independent processes or cooperative? So they need to communicate, they need to take the help of another process. So if you see this point, information sharing, there are several reasons for providing the cooperative processes. Information sharing, since several users may be interested in the same piece of information, for instance a shared file, you must provide an environment to allow the concurrent access of such information. Computational speed, just now I told you this example, I told you computational speed. There are big work is there. What you will do, you will divide the work into multiple works. What is the benefit of providing the multiple, dividing the big task into multiple tasks? Speed up. Will you agree? What is the use of this means? Speed up. Try to read this point. If you want, yes, like a functions, every function is doing its work, like every process will do its work. If you want a particular task run faster, you must break up into subtasks. Again, if you want to perform a task to run faster, you must break up into subtasks, each of which will be executed in parallel to others. Each of which will execute in parallel to others. Will you agree? This is the second reason why the cooperative processes required. Third reason is modularity. You can, if you may want to construct the system in modular fashion, dividing the system functions into separate processes or threads. You want to construct a system in a modular fashion so that you can divide the big system into small functions, or they're called as a separate processes or threads. Next one is a convenience. convenience purpose, cooperative processes are required. Even an individual user may work on many tasks at the same time. For instance, user may editing, printing, and compiling in parallel. For that also, I need a cooperative processes. So why we need a cooperative processes? One, information sharing purpose, we need a cooperative processes. Second, computational speed up to increase the work to be done faster. Then you need to divide the big task into small works, and you need to assign to every process. Third one is modularity, similar. Fourth one is a convenience. Observe, cooperative processes require inter-process communication mechanism that will allow them to exchange the data and information. Again, if cooperative processes wants to communicate between each other, our operating system or our kernel is supporting the mechanisms called IPC mechanisms, inter-process communication. Again, inter-process communication. Now, can you tell me, not nowadays, we are in a world where communication plays a major role. Will you agree? We are in a world where communication plays a major role. One process is sharing the data to another process is reading the data. Now tell me, if you have the WhatsApp group, so what you will do, one person will share the data, other persons will read the data, can access the data. Sharing information is required. Modularity purpose, convenience purpose. So cooperative processes are required. So cooperative processes require a mechanism. Cooperative processes required a mechanism that will allow them to exchange the data and information. Now, can you tell me all the processes are present where? In a hard disk or in a RAM? Can you tell me all the processes are present where? In a hard disk or in a RAM? Can I say operating system will not allow one process to access another process memory? Will you agree? Operating system will not allow to access one process memory with another process. Now tell me, if one process is trying to access other process memory, will you agree you will get a segmentation fault? So our kernel is supporting the mechanisms to communicate between the processes. Those mechanisms are called as IPC mechanisms. The name itself tells you, using this mechanism, what we can do. Using this mechanism, so what we can do, we can communicate, we can create a system where multiple processes can communicate between each other. Internal communication, yes. So IPC concept, there are two categories will be there. One is for communication purpose and another one is for synchronization purpose. We required IPC for two purposes. One is a communication purpose and another one is a synchronization purpose. In a communication, again, two purposes: data sharing, data transfer, and sharing the memory. Data transfer, sharing the memory. And this diagram you will understand better once we complete the total IPC. Again, this diagram you can easily understand once I totally finish the IPC. In a data sharing, again, two things: byte streaming, message type of communication. in a byte streaming pipe, FIFO, in a message queue, in a shared memory, semaphores, record lock, all these things, all these concepts we are going to discuss one by one. So overall, the discussion is, the topic is what? Overall, the topic is what? Topic is IPC, interprocess communication. In this IPC, we are going to talk about the pipe concept. We are going to talk about FIFO concept. We are going to talk about message queue. We are going to talk about a shared memory. We are going to talk about semaphores. We are going to talk about a record lock. This record lock is also called as file lock. So each concept we need to discuss individually. So what is the first IPC mechanism we are going to discuss today? What is the first IPC mechanism we are going to discuss today? That is pipe. What is the first IPC mechanism? Inter-process communication we are going to discuss. That is the pipe. So what I will do is, before that, try to understand what I'm trying to do is mkdir pipe, sorry, IPC. I created one directory called IPC. In which directory I created? Can you tell me? I created one directory called IPC. In which directory I created? In FM. Will you agree? Are you able to see my screen? Are you able to see my screen? Command prompt. Okay, just a minute. Just give me 1 minute of time. Okay. Now tell me. I created one directory called IPC in FM folder. I'll change my directory cd IPC. In this mkdir pipe, mkdir FIFO, mkdir message queue, mkdir shared memory, mkdir semaphore, mkdir record lock. Now will you agree? I created multiple folders for every topic what we are going to discuss in the next sessions. I created multiple folders what we what we are going to discuss in the multiple sessions. Now observe, I don't know you know it or not. In this FM folder, there is one file called header file. In this FM folder, there is one file called header file. Now observe, I'm going to use ln // header.h/. I'm not using the cp command. I'm using the ln command. Can you tell me what is this ln command? I'm not using the cp command. I'm using the ln command. Can you tell me what is that ln command? Can I say hard link? Link file. Now tell me, in this header.h, if I update, in this header.h, if I update, in a FM folder, header.h is going to be updated or not? In the present working directory, when I update this header file, in a FM folder, whatever the header.h is there, that is going to be updated or not? Answer is yes, it is going to be updated. So from now onwards, I will not use the cp command. Again, from now onwards, I will not use the cp command. I'll use ln command. From now onwards, I'll not use cp command. I'm going to use ln command. Is that point is clear? So that if I update here, that is going to be updated in this folder header.h. Now can you tell me why I created a separate header.h? Can you tell me why I created a separate header.h? Because we are in future, already how many header files are included? Already 11 is included. In future again around 10 we are going to include more. So can I say header files increasing day by day? So that is the reason I created a separate header.h. Now in which directory we are working? Can you tell me? In which directory I am working? Will you agree? Pipe. As I told you, today's our discussion will be on the concept called pipe. So note it down. The functions involved in this IPC mechanism. Note it down. Functions involved in this IPC mechanism. The functions involved in this IPC mechanism is pipe, functions involved in this IPC mechanism is pipe, read, write. These are the functions involved in this IPC mechanism. Pipe, read, write. So before that, we need to discuss some theoretical concept about this thing. Man 7 pipe. All of you observe here. Man 7. Can you tell me man page 7 is for what purpose? Can anybody tell me man page 7 is for what purpose? Man page 7 is for overview. Man page 7 is for overview of pipes and FIFOs here. Now observe, pipes and FIFOs, also known as named pipe, provides a unidirectional communication channel. I'll copy this and I'll paste it in this new file. Just give me 1 minute of time. All of you observe this. Pipes and FIFOs provides a unidirectional IPC channel. Unidirectional means like this is the pipe. Suppose generally this is the pipe. Can I say that data will travel in only one direction? A unidirectional pipes and FIFOs provides a unidirectional interprocess communication channel. This is like a buffer. This is a channel, IPC channel. A pipe has how many ends? Can you tell me a pipe has how many ends? Read end and write end. Data written to the right end of the pipe can read from the read end of the pipe. Again, pipe has two ends. One is a right end and another one is a read end. Data written to the right end of the pipe can be read from the read end of the pipe. Suppose if one process writes the data from the right end, another process can read the data from the read end. Again, suppose if one process writes the data from right end, so another process can read the data from the read end. Again, suppose a process writes the data from the right end, so another process can read the data from the read end. So pipes and FIFOs provides a IPC channel. This is one channel. This is one method, one buffer. A pipe has a read end and write end. Data written to the right end of the pipe can be read from the read end of the pipe. So one process can write the data from the into the pipe. So another process can read the data from the pipe. One process can read the data, write the data into the pipe, so that another process can read the data from the pipe. Next, observe. A pipe is created using the pipe system call, which will create a new pipe and returns two file descriptors. One is referring to read end of the pipe and other is referring to the right end of the pipe. I'll copy this. These points I'll put it in a LMS later. Now observe, a pipe is created using which system call? How to create a pipe? How to create a pipe using the pipe system call. What is the meaning of two here? What is the meaning of two here? That is a system call. So a pipe is created using the pipe system call. A pipe is created using the pipe system call, which will create a new pipe and returns two file descriptors. Now here again the file descriptor concept comes. So when you create a file, you will get only one file descriptor. Again, when you open a file or when you create a file, will agree, you will get only one file descriptor. But when you create a pipe using this system call, you will get two file descriptors. Again, when you create a pipe using this system call, you will get two file descriptors. One is referring to read end of the pipe and other one is referring to the right end of the pipe. Two file descriptors you will do. With one file descriptor, you can read from the pipe. With one file descriptor, you can read from the pipe. With another file descriptor, you can write into the pipe. Again, with one file descriptor, you can read from the pipe. With another file descriptor, you can write into the pipe. Getting the point? With one file descriptor, you can read. With one file descriptor, you can read from the pipe. With another file descriptor, you can write into the pipe. With one file descriptor, you can read from the pipe. With another file descriptor, you can write into the pipe. So when you create a pipe using the pipe system call, you are going to get two file descriptors. One is for reading purpose and another one is for writing purpose. And one more important point here, try to read this very carefully. Pipe can be used to communicate, to create a communication channel between related processes. Related means pipe can be used to communicate between related processes. Can you tell me what is the meaning of related? Means parent and child. Related is nothing but parent and child. Again, pipe is used to create a communication channel. Pipe is used to create a communication channel between related processes. So Using this pipe, only parent and child can communicate. Unrelated processes cannot communicate. Using this pipe, only related processes can communicate. Unrelated processes cannot communicate. Is this theoretical concept is clear? So pipe and FIFO provides a unidirectional inter-process communication channel. Means it will provide one method, one channel, one buffer, one mechanism to communicate between the processes. A pipe has read end and write end. A pipe has read end and write end. Data written to the right end of the pipe. Data written to the right end of the pipe can read from the read end of the pipe. Again, the data written to the right end of the pipe can read from the read end of the pipe. A pipe is created using a system call called pipe system call, which creates a new pipe and returns a two file descriptors. One file descriptor is referred to the read end and another file descriptor is referred to the write end. And the pipe is used to communicate between only pipe is used to communicate between related processes. Meaning is, using this pipe, parent and child can communicate. Okay, now what I'm going to do is I'm going to create one program. Try to understand what is that program I'm going to do. I'm going to create one process. Suppose this is a parent process, this is a child process. So parent is going to scan the data from the keyboard. Copy this diagram. Parent is going to scan the data from the keyboard. Hello world data, going to put it into the pipe. Child is going to read that hello world and printing on the screen. Child is going to read and printing on the screen. Again, I'm going to create a scenario where parent is going to read the data from the keyboard and putting the data into, can you tell me? Parent is going to read the data from the keyboard and putting into parent is going to read the data from the keyboard and putting into the pipe. Pipe which end it need to write? Can you tell me pipe which end it need to write? Can I say right end? It need to write to the right end of the pipe. So then what is the child need to do? Can you tell me what is the child need to do? Will you agree? Child need to read the data from the read end, that hello world. In the child, it need to print it. This is the first target in this IPC mechanism. So this is the first goal. This is the first target we are going to do. Is all of you copied this diagram? Is all of you copied this diagram? If yes, type S in the chat box. Again, I am requesting you. Some of the students are sleeping and listening the lecture. So that is not the way of attending the lectures online because their video is on. Some of the students are sleeping and listening the lecture. You are not watching the movie. So my sincere request to everyone is you should be ready with pen and paper when the class starts. I hope the student who is sleeping and listening might have alerted. So be very careful. So it is not like a things. So all of you copied this diagram. Is all of you copied this diagram? Okay. So how to create a pipe? How to create a pipe using pipe system call. How to create a pipe using pipe system call. One of the student is asking one question. Let me read the question. Sir, if there are two processes, parent and child process have child one. That's what. Related processes means like this. This is the parent. There are multiple childs. And this multiple childs may have some multiple childs. So all this can communicate. This child can communicate with this grandparent. So this child can communicate with this parent. This can communicate because all are related, right? BE8F1, got the point? Child 1 can communicate with child 2. Child 1 can communicate with the child 2. All these things we'll discuss it. First, let me start the programming. So all these things we'll discuss it. Okay. Okay. How to create a pipe using the pipe system call. How to create a pipe using the pipe system call. Man to pipe. Copy this prototype. Copy this prototype. Man to pipe. So which header file I need to include? Which header file I need to include? unistd.h. Return type of pipe is what? Integer. But can you tell me what you need to pass to the pipe? Observe this. Can you tell me what you need to pass to the pipe? You need to pass an array base address. You need to pass an array base address. I'll show you. It will be more clear if I start program vi 2509 underscore 2.c hash include. In our header file, is it unistd is already there? Can anybody guess? unistd, yes, line number 2. unistd is already there. Okay, unistd is already there. So what is the task? I'll write the task here. Parent need to create a pipe and scan the data from user, put it into pipe, and child need to read the data from pipe and print on the screen. Just for reference purpose, again I written here. Just for reference purpose, again I written here header.h void main. Now can you tell me what is the storage type of this array? What is the storage type of this array? Can I say auto? What is the default value of p of 0 and p of 1? What is the default value of p of 0 and p of 1? Garbage. But what I will do now, what I am passing to this pipe function? Can you tell me what I am passing to this pipe function? I am passing array of two integers base address. I am passing array of two integers base address. I am passing array of two integers base address. So in that array, what I am going to get? In this array, I am going to get two file descriptors. In this array, I am going to get two file descriptors of the pipe. So 0, 1, 2 is already reserved, 0, 1, 2 is already reserved. Can you tell me what is P of 0 holds? You will get 3 and 4, two file descriptors. You will get two more file descriptors, 3 and 4. P error pipe printf P of 0 is equals to percentile D slash n comma P of 0 and printf P of 1 is equals to percentile D slash n comma P of 1. Will you agree? Pipe is created success. Pipe is created success. And two file descriptors we got 0 and 1. 1 refers to, sorry, just let me show you the prototype here. Observe, pipe creates a unidirectional data channel that can be used for communication between the processes. The array pipe FD is used to return the two file descriptors referring to the end of the pipe. P of 0 refers to P of 0 refers to P of 0 refers to read end of the pipe. P of 1 refers to P of 1 refers to P of 0 refers to read end of the pipe. P of 1 refers to write end of the pipe. Again, P of 0 refers to the read end of the pipe. P of 1 refers to the right end of the pipe. Observe, I'll write it here. P of 0 is equals to read end. P of 1 is equals to right end. P of 0 refers to read end and P of 1 refers to right end. Now who need to write the data into the pipe and who need to read the data from the pipe? I'll write it here something. Lower file descriptor, that is P of 0 refers to read end and P of 1 refers to write and again p of 0 refers to read and p of 1 refers to write and p of 0 refers to read and p of 1 refers to write and. Now can you tell me which process need to write the data into the pipe and which process need to read the data from the pipe? In this example, which process need to write the data into the pipe? Which process need to read the data from the pipe? Which process? Can I say parent process? Parent process need to read the data from the pipe. Need to write the data into the pipe, and child need to read it. Is clear? Is that point is clear? Now observe what I'm going to do is, if a fork else. Now tell me, if belongs to the body of the if who will execute the body of the if who will execute BE901. It is wrong. The body of the if who will execute parent. The body of the else who will execute child. The body of the if parent will execute. If I might have written if a fork double equals to 0, then if I might have written if a fork double equals to 0, then body of the if is executed by the child, else is executed by the parent. Now as per the specification, what the parent need to do? Printf in parent, enter the data. In parent, enter the data. Now can I say whatever the array I am declaring here in line number 18, this is exclusive parent variable. In line number 18, whatever I am putting here, will you agree that is the exclusive parent variable? So now I am scanf percentile s comma s. After scanning, what the parent need to do? After scanning the data from the user, what the parent need to do? Need to write it into the pipe. Write. What is a pipe file? Write file descriptor. What is a write file descriptor here? Is it a p of 0 or p of 1? What is a write file descriptor? P of 1. S. strlen of s plus 1. P error parent write. Parent is writing. Is it success or failure? I'm using the P error, I'm writing it. Now what is the child need to do? What is the child process need to do? Read character S1 of 20, printf child before read system call. Read p of 0 s comma s1 comma s1 comma size of s1, printf in child After read, S1 is equals to percentile S, comma S1. Now, can you tell me which type of data parent is, which type of data parent is putting into the pipe? Which type of data parent is putting into the pipe? Will you agree it is putting string data? Will you agree it is putting string data? Now the child is reading. Now I need to tell you one point. If pipe is empty, if pipe is empty, read will block. One important point here. Child is reading the data from the pipe. Suppose the pipe is empty. Suppose the pipe is empty. Read system call will block. Suppose the pipe is full, write will block. If pipe is like a buffer, like an array. Pipe is full, sorry, write will block. Now can you tell me this buffer is created where? This is the kernel supported mechanisms. Can you tell me where this buffer is created? In a user space or in a kernel space? This is the kernel supported mechanisms. Can you tell me where that pipe is created? In a user space or in a kernel space? In a kernel space. We'll discuss what is the size of the pipe, BE8F1. Slowly we'll discuss what is the size of the pipe and all other things, limitations and so many things. Now line number 18, 19, 20, 21, 22, who will execute? Line number 18, 19, 20, 21, 22, who will execute? Parent. Line number 27, 28, 29, 30, who will execute? Line number 27, 28, 29, 30, who will execute? Child. Now will you agree? Initially the pipe is empty. This is the parent process is writing. This is the child process is reading and printing on the screen. Will you agree? Initially pipe is empty. So can I say this read will block the child execution? This read will block the execution of the child. Initially pipe is empty. So this read will block the child execution. Let's see this. Let me compile the code and let me show you. Let me compile the code and let me show you the output here. So pipe is created success. Pipe is created success. P of 0 is a read end. P of 1 is a write end. Parent is saying that enter the data. In a parent, scanf is blocking. In a child, read is blocking. Again, in a parent, scanf is blocking. In a parent, scanf is blocking. In a child, in a parent, scanf is blocking. In a child, read is blocking. All of you are observing this point. In a parent, scanf is blocking. In a child, read is blocking. Now if I type HELLO, see, parent written the data success, child also read the data, hello. So parent is putting the data into the pipe, child is reading the data from the pipe. Now can you tell me, initially In a parent, which function is blocking? In a child, which function is blocking? In a parent, scanf is going to block. In a child, read is going to block. Initially, in a parent, scanf is going to block. In a child, read is going to block. If accept this, if this observation is clear, type C. If this observation is clear, type C. As I told you, if any process is trying to read from empty pipe, if any process is trying to read from empty pipe, if any process is trying to read from empty pipe, read will block. If any process is trying to write into a pipe where pipe is full, write will block. One of the student asked, sir, how can I find out the size of the pipe? Very simple. You keep on writing the data into the pipe, character by character, character by character, character by character, increment the count. At one stage, pipe becomes full. Don't do any reading operation. Just keep on write the data into the pipe. At one stage, write will block. Pipe is full, write will block. At that stage, what is the counter is there? That is nothing but, at that stage, whatever the counter is there, that is nothing but the size of the pipe. At that stage, whatever the counter is there, that is nothing but the size of the pipe. That is also we'll discuss it. First, let's discuss this clearly. Now, in a parent, which line will block the parent execution? In a parent, which line will execute the parent, block the process? Can I say line number 20? In a child, which line will block the process? 29. Why line number 29 will block? Why line number 29 will block empty? Now tell me, if it HTLO, who is getting this data first? Who is getting this data? Parent. In a scanner. After data from the keyboard, what the parent is doing? Parent is reading BE8 F1 is asking, sir, if you suspend the child and give the input in the parent, what happens? The pipe will be, the data will be there in the